सो हम रोटर स्लिप को डिस्कस कर रहे थे। यानी practically it is impossible for rotor to catch up with the stator rotating magnetic field. So if this happen, यानी अगर आपका जो रोटर है वो और रोटेटिंग मैग्नेटिक फील्ड का जो स्पीड है वो बराबर हो जाए, सो आपके पास जो है उसका रिलेटिव मोशन जो है वो ज़ीरो हो जाएगा। जब रिलेटिव मोशन ज़ीरो हो जाएगा, सो देन देयर विल बी नो ईएमएफ इन द रोटर वाइंडिंग. No EMF means no current, no flow of current, and whenever there is no flow of current, so there will be no torque. So practically it is impossible for the rotor to catch up with the rotating magnetic field. So the rotor will always rotate at a lesser speed than rotating magnetic field, and this difference between the speed depends upon the mechanical load on the motor. So जो आप लोड बढ़ाते जाते हैं इंडक्शन मोटर के ऊपर, तो आपके पास जो रोटर का स्पीड है वो कम होता जाएगा, लेकिन रोटेटिंग मैग्नेटिक फील्ड का जो स्पीड है वो कांस्टेंट होगा, क्योंकि वो डिपेंड करते हैं आपके फ्रिक्वेंसी पे कि स्टेटर को आप जिस थ्री फेज सप्लाई से एनर्जाइज कर रहे हैं उसकी फ्रिक्वेंसी क्या है, और स्टेटर के ऊपर नंबर ऑफ पोल्स कितने हैं, तो उसकी स्पीड तो इस चीज़ पर डिपेंड करती है, ठीक है। और रोटर की स्पीड जो है वो लोड के साथ वेरी करती है। So slip is actually the difference between the synchronous speed and rotor speed. So when you subtract the synchronous speed and the motor speed, so this difference is called slip. स्लिप स्पीड, इस डिफरेंस को हम क्या कहते हैं, इसको हम स्लिप स्पीड कहते हैं। So slip speed is actually the synchronous speed minus the rotor speed. One term is called the percent slip. So the percent slip is actually the slip speed divided by the synchronous speed into 100%. Now we know that the slip speed is actually the difference between the synchronous speed and the rotor speed and divided by the synchronous speed. So this is actually the percent slip. This is the equation for slip speed, and this is the relation for the percent slip. So these are two more important concepts. What is the percent slip and what is the slip speed? So now let's come toward an example. In this example, we are given that we have a two-pole three-phase induction motor, and it has a speed of 3460 rpm, and we have to calculate the synchronous speed, the slip in rpm if the supply frequency is 60 hertz. So first of all, we have to write the given information, or we have to write the given data. So we are given that the number of poles are 2. This is a three-phase induction motors, and its rotor speed is actually 3460 rpm. We have calculated the synchronous speed. We have calculate the synchronous speed, and we have to calculate the slip speed. We have to calculate the slip speed. If the supply frequency is actually 60 hertz. Now we know that the synchronous speed is actually what, 120 into F divided by P. So this synchronous speed is 120 into F is 60 divided by number of poles are 2. The synchronous speed is 3600 rpm. Now we know that the slip speed is actually the difference between the slip speed. It is actually the difference between the synchronous speed It is the difference between the synchronous speed minus the rotor speed. So the synchronous speed is 3600 rpm and the rotor speed is 3460 rpm. So the slip speed is actually comes out 140 rpm. Now we have to calculate about the percent slip as well. So the percent slip is the slip speed divided by the synchronous speed. So the slip speed comes out 140 rpm and the synchronous speed is 3600 rpm, and as we are going to calculate the percent slip, so into multiply by hundreds, so it comes out to be 3.88. So the percent slips comes out to be 3.88%.